Hey YouTube, my name's Neil and I'm the head of maths at MES for my EdSpace. In this video today we're going to tackle solving trigonometric equations. First, we're going to prove the fundamental principles that we're going to be using in most questions, and then we're going to follow some simple rules to solve any single question any examiner can give you. If you like the video, please subscribe and like, share with any friends that you feel would benefit from this, and feel free to follow me on Instagram. Details to everything are down in the description. I hope you enjoyed. Hey everyone, we all know from GCSEs anyway that the definitions of sine, cosine and tangent are all to do with the right angled triangle, but where do they all come from? Well, they all come from the unit circle, if you didn't know already. So if I draw my axes, drawing lines is alright, but it's really the circles. So I'm going to do my best to draw a circle. Okay, I only need to do this side anyway. Now, it's a unit circle. You lot should all know that a unit circle means that the radius is 1. So if I draw a line to the circumference and write 1, and I form a right angled triangle. Now, I obviously drew this in a random place, right? So I'm going to put theta here. Now, what I need to find is this opposite side, and I need to work out this adjacent side in terms of 1 and theta. Now, like I said, you all know what the definitions of sine and cosine are, right? So we know the hypotenuse here. And say I want to find the opposite. We know that sine, SOHCAHTOA, sine is opposite over hypotenuse. So I'm going to say sine of the angle theta is the opposite divided by the hypotenuse, which is 1. Which actually just means that the opposite is just sine theta, right? Because anything over 1, it doesn't do anything. So this opposite side is sine theta. By assumption, we probably know what the adjacent side would be, but I'll write it down anyway. Cos theta is the adjacent side divided by the hypotenuse 1. So also the adjacent is cos theta, because like I said, anything divided by 1, it doesn't do anything, right? We're doing Pythagoras to all the sides, yeah? So we're doing cos theta squared. Now, we don't write it as cos theta squared. We say cos squared theta. So that's this side squared plus the opposite side squared, which is sine squared theta, equals this side squared. Well, 1 squared is just 1, right? And here is our first equation. Yeah, this is the Pythagorean identity. This is a we call it a Pythag identity. Yeah. Now, in my full course, I would be doing questions to do with this equation. We're not going to do so much on, well, we're not going to look into it that much today, just because we need to keep it short, a bit shorter. But the other thing, remember we were doing SOHCAHTOA, right? Now, we've dealt with sine being the opposite divided by the hypotenuse. We did cos. The only thing we didn't do was tan, right? Now we know tan is the opposite side divided by the adjacent side. Now when you look at the triangle, remember the opposite side was sine theta, right? And the adjacent side was cos theta. So when we apply that, tan theta is the opposite sine divided by the adjacent cos. There you go. Nice, Ibrahim. So hopefully you've learned, so maybe you've done this before, but you didn't know where it came from. These are the two AS formulas that we need to know, and this is where they come from. Keep in mind also that as examiners, we'll never ask you to prove this, but the way I like to teach you guys is to make sure you understand that I'm not making stuff up. It's not just being regurgitated out of a book. You always want to know where things come from so that we apply it properly. Yeah. So the first one, sine squared plus cos squared is 1. Why does it all originate from the circle? Well, trigonometry just means measure of angle, and when we do mechanics and stuff like that, we like to do circular measure, and we measure. It's kind of like a foundational thing. So the circle kind of produces the triangle that we are interested in order to do trigonometry. Trigon means measure of angles, metry of 3 sides. And in order to measure in order to fix the hypotenuse, because we're talking about the same triangle, we want to fix the hypotenuse. And the only way we can do that is by using a circle which has a fixed radius. Yeah? Okay. Now this is where, like I was saying at the beginning, students do so many different answers or ways to, students give like 100 different ways of answering these questions. What I'm going to show you is a really nice, clean way where us examiners want to see just this. Yeah, we don't want to see you drawing graphs. There's another one. There's a pet peeve, way of solving trig, which I'm going to check how many of you actually use this way if you're in year 12 or going into year 13. Or if you did further maths GCSE, you might have been taught this way as well. Okay, so solving. Find all values of x in the interval between 0 and 360 such that sine x is 1 over root 2. Fizzers got it. They've discovered my pet peeve. More on that later though, yeah? But yeah, you've got it. So just if this is new to you, what we're trying to say is we have the sine graph, whether you're in GCSEs, you'll know what the sine graph is. So here's the sine graph. I'm saying if you have the sine graph between 1 and -1, what x values would produce sine of those x values are 1 over root 2. 1 over root 2 is here. Yeah, between 0 and 360. Now what we'd do is we'd read across. Yeah, we'd read across like this. And you can see there's two answers in the range. We basically want to know what they are. Yeah. Now, if you remember from Monday, hopefully you've all brought your calculators. And we want to make sure we're in degrees mode in year 13. And in fact, one of my lectures I'm doing this summer, we're going to talk about radians. Make sure you're in degrees mode. To get this first value over here, all we need to do is we need to do inverse sine of both sides. So this is something that you do at GCSEs. Yeah, this is all the same stuff. When you use the sine rule, you do your sine A over A equals cos A or cos B over B, and then you do your inverse sine, not cos B over B, sine B over B. Let me talk about the cast diagram in a second. So we have sine x is 1 over root 2. Now again, this is what I want you guys to show in the exam. Yeah. Once you have your question, you rewrite it. I want you to say what you're doing to both sides. So you're doing the inverse of sine to both sides, and you're showing that you're cancelling out sine. Now in your calculator, when you do inverse sine, this is an exact value, but most students would just type this in. So I'll just pretend like I'm a student right now. You get 45 degrees. Yeah, I keep losing my 45. There we go. Now this value here is 45. Now I'm only going to explain this once because you actually only need to know this once. And I'm going to show you a cool diagram later on. Now with the sine graph, this first, call it, what could we call that? Hump, we'll say, is symmetrical. Now it's symmetrical about 90 degrees. Yeah, this is symmetrical about 90 degrees. I'm interested in finding this value, right? Now the way we do that is very simple, is we know that, because I'm using light colors I can't see on the screen, we know this is 180 degrees. All you do is to go to 45 degrees using symmetry, we're going in from 45, oh sorry, in from 0. So to get to this square, we go in from 180. So all you need to do to get the second value is you just do 180 take away 45. So the next x value is 180 take away 45. And in this case, that's 135 degrees. Now there's some lingo you need to use here. This second value is called the secondary value, or the SV. The first value we call the primary value. Yeah, so this is the primary value. This 135 is the secondary value. Now, sine, cos, and tan all have a simple rule to find the secondary value. For sine, all you do is 180 minus the first value. That's it. Yeah. I'm going to summarize this for you lot. But for sine, doesn't matter what you're dealing with, to find the secondary value, you do 180 take away the primary value. Just like that. And you do that doesn't matter if that primary value is negative or principal solution. Some people call it principal solution. I like to call it value, but yeah, there's different ways of saying that one. Now, cos, it's not the exact same way to find the secondary value, but let's explore cos a little bit more. Why don't we do it in a different color? So we have cos x is minus 1 over root 3. And again, we want to indicate what we're doing to both sides. Cancel, cancel. Now let's just say for this, we're going to do it to 1 decimal place. Yeah, so inverse cos, hopefully we've all got our calculators now. 1 over root 3. 125.3 we'll say. 125.3 degrees. Now let's look at the cosine graph. Oh, can you see that line? Look how perfectly I got that next to my head. So here's the cosine graph. We should all know how to draw the cosine graph by now, right? 0, 360. 1, minus 1. Minus 1 over root 3 is somewhere down here. And what I've just done is I've found the first primary value or principal solution, if that's how you call it, 125.3 degrees. Now, cosine's very, very simple. So all you do with the cosine graph is it's kind of similar to the sine graph, but the cosine graph has symmetry at 180 degrees here. So from 0, you're going in 125.3 degrees, which means to get the other solution, which is over here, can you lot tell me in the chat what do you need to do? So you have to go in 125.3. What do you need to do to get to that secondary solution? Put that in the chat. What do you need to subtract from? You can have a think about it. Take from 360. Nice. Hey, we're getting it. There you go. We subtract it from 360. So to get the secondary, hey, nice. We're all getting this. 360 minus 125. Okay, so 360 minus the answer is through 234.7. Where's my thing gone? 234.7. Yeah? Now again, this happens every single time. Yeah? Every single time. Cos to find the secondary value, you do 360 minus the primary. And that does not change at all. It does not change. Yeah? Here's my diagrams. This is a summary. Yeah? Now, this is where, you know, students do way too much. First thing that students do is they either draw the diagrams every single time. As an examiner, I don't want to be seeing your diagrams, yeah, because people draw some awful diagrams. Obviously, you lot draw nice diagrams, yeah, but another one you lot have picked up already is, oh yeah, Fizzer did, is the cast diagrams. Put in the chat if you use cast diagrams, or if you've been taught cast diagrams. How many of you, put a plus in the chat if you've been taught using cast diagrams? I don't want to see too many, but how many of you have been taught cast diagrams? Never heard of them? Good, good. Some of you are saying no idea, but look, there's some pluses there. Yes, that's quite a lot. Okay, they've been taught but never used. Some questions asked for. Okay, so Shalon, they wouldn't in a solving question, they would never ask you to draw the diagram as part of the solution. Yeah. Okay. Now the thing about cast diagrams. Yeah, listen very carefully. All cast diagrams, so if you don't know what cast diagrams are, don't worry. But to those, because quite a few of you have been taught cast diagrams. Cast diagrams are only there to tell you where the sine, cos, and tan function are positive. That's it. Yeah. So between 0 and 90 degrees, every function is positive. Between 90 and 180, only sine is positive, etc. That's it. Yeah. But the reason Diana, I'm going to show you using examples how you can do it flawlessly, yeah? The thing about class diagrams is the book uses class diagrams because it's the easiest way for them to explain it to you in just text form. But it's not a practical way of doing it. So how do we solve? If I'm marking your exams as an Edexcel examiner, if I'm marking your exams, all I want to see, when I give you a question, you do either inverse sine, inverse cos, or inverse tan. That gives you your primary value. It doesn't matter whether the function is positive or negative. Yeah, that's your primary value. The second step is you work out the secondary value using what's at the top. So if you've done inverse sine, you do 180 minus your primary value. If you're dealing with cos, you do 360 minus the primary value. If you're dealing with tan, we didn't draw the tan graph, but you can see it on my diagram there, is you always do 180 plus. These three things is the only thing you need to remember when it comes to trig, when it comes to solving. And this is going to be applicable in year 13 as well, yeah? So the way I'm showing you to solve right now, you're going to use in year 13. And all I'm asking you is to remember these three things. Now, depending on the range, yeah, because I'm going to discuss questions where the range is a little bit bigger than between 0 and 360, is once you have your primary and secondary value, all you do is you add and minus 360 to work out other values in the range, because we know the sine, cos, and tan graph repeat themselves. That's all, yeah? Very, very simple. So 3 steps. You do inverse sine, inverse cos, inverse tan. You work out the secondary value by doing 180 minus, or 360 minus, or 180 plus, if you're dealing with tan. Then, third thing is, depending on the range, you add and minus 360 to work out the other values. That's it, yeah? Let me show you how I want to see you answer a question, yeah? In this, I am not going to draw any graphs, yeah? So we're going to solve 3 sine theta equals 4 cos theta. And the range is between between minus 180 and 180. So the first thing when we solve, I'm trying to show you a lot of range because we don't have all the time. We're only doing one session on trigonometry this summer. Is when it comes to solving, we want to have it as one function only. So previously I showed you how you do the sine and the cosine. The next thing is what happens when sine and cosine are mixed. Well, same principle, we need to convert it into one function only. And the way we do this is we know, because I showed you at the beginning, we know that tan theta is sine over cos, right? There you go, Hannah, you know it. So we're going to divide both sides by cos theta to get tan. By dividing by cos theta, this disappears. And we're left with 4. And then sine theta over cos theta is tan theta. So we have 3 tan theta. Then next thing is we don't want coefficients. Yeah, we want to rearrange for tan. We're going to divide both sides by 3. So we're going to divide both sides by 3. The 3 goes. Now all we're solving is tan theta is 4/3. Now we're going to follow my 3 steps. Yeah, step 1, we're going to do inverse tan. Keep losing my. We're going to do inverse tan. This is how I want you guys to structure it in an exam. Okay, we'll do 1 decimal place. So inverse tan, or 4/3. Okay, 53.1. Where's my thing gone? Here it is. 53.1 degrees. Remember, what do we call that? We call that the primary value. Yeah? Next thing is, remember, allow cast. We're not using cast diagrams here. What did I say? To work out the secondary value for tan, we do 180 plus. So to work out the secondary value for tan, we do 180 plus 53.1. So in our calculator, we're just doing plus 180 to 233.1. 233.1. Now, what you may notice, yeah, is 233.1 is not in the range. So what I like to do is, as I go along, I tick and cross what is and isn't in the range. Yeah. Now this is very simple. Yeah, we've just finished step 2. Step 3 is we add and minus 360 in order to find other values in the range. Now the upper bound for the range is 180 and the lower is minus 180. If you look at 233.1, that is not in the range. Would you add or minus 360 to get another value in the range? Well, we're not going to add 360, right? Because it's already out the range on the positive side. The next step is we're going to take this 233.1 and we're going to minus 360 degrees. And that gives you minus 126.9. Minus, where's my mouse gone? There it is. Minus 126.9. And you can see that is in the range, right? That's it. I'm done. Theta, the only two values is 53.1 and minus 126.9. Nice and simple. Did we need to draw any cast diagrams? Did we need to draw any graphs in general? No, we didn't. We just needed to do primary value, secondary value, and then add and minus 360. So that last step was here. Yeah, adding and minusing 360. Yeah. If we were doing, so Imran, if we were doing sine, I would have done inverse sine. Yeah. Then I would have done 180 minus, and then yeah, I would have added a minus 360. Hussein, 360 just because the sine and cosine graphs. Remember, it comes from the circle, right? 360 degrees in a circle, sine, cos, and tan. We derive them all from the circle. That's why we're adding and minusing 360, because we're basically just going around 360 degrees. Yeah. So sometimes we want to go clockwise 360. Sometimes we want to go negative 360. Okay, so 2 more questions. Solve each equation for x in the interval between 0 and 360. Give your answer to 1 dp. Okay, now there's one extra thing that we need to be careful of. Cos x plus 45 is, okay, that shouldn't say 2, that should say a half. Give your answer to 1 decimal place where necessary. So first thing, we do inverse cos, as always. Some of you guys might know actually what inverse cos of a half is, but I'm going to pretend you're a student. So, well, really it's 60, but I'm going to type it in anyway. Yeah, 60, just to make sure, yeah, I'm not getting this wrong. So we have x plus 45 is 60. That's our primary value. Now, if you check between 0 and 360, that is in the range. Now, one thing you guys need to be very careful of is, I'm only mentioning it now because I haven't explained this already, is this range here is for x, yeah? But when you look at my function, can you see it says x plus 45? These things don't match up. In order for us to apply the rules I've been telling you so far, you need to make sure that they both read x plus 45. And what that's called is modifying the range. You can call it MR. Yeah, modifying the range. This middle angle here needs to read x plus 45. And the way we do that is just by adding 45 to every single number here. So 0 plus 45 is 45. Then we get x plus 45. And then we have 360 plus 45 is 405. Everything we do at the moment is going to be relative to the modified range. Yeah. Now, again, we've just done step 1, yeah, of doing inverse cos, inverse sine. Next step, secondary value. Hopefully your memory is okay here. We do 360 minus to get the secondary value. And in this case, we got 300. Now you can see within the modified range, both of these are actually in the range, right? It's good we modified the range because that 45 is quite close to 60. If you didn't modify the range, sometimes this primary value is not actually in the modified range. So going forward, the first thing I'm going to do is modify the range. Yeah. Now we've got a primary value and our secondary value. The next thing is we need to decide if we want to add or minus 360. If you take 60, which is already in the range, and you add 360, that's obviously going to come out of the range, but you should verify that. 60 plus 360 is 420. That's bigger than 405. And we're not even going to try and minus, right? It's just going to be way too small. Next one, 300. Are we going to add 360? Definitely not. Are we going to minus 360? Or 300 minus 360 is minus 60, which is also not in the range. So our only two answers here is 60 and 300. Yeah, these are in the modified range. Remember, we set the modified range to be x plus 45. Yeah. Then finally, we just subtract 45, and then we get our final solution. 60 minus 45 is 15, and then 300 minus 45 is 315. If my number, no, wait, what am I talking about? 315. That's terrible. This is why you should always use a calculator. Yeah, 255. I've got my calculator with me, by the way. Okay, so that's how we do part A. Remember, like I said, you don't need to do the class diagram. You don't need to do any graphs. You just do primary value, secondary value, and then you think, or with your calculator, am I adding or minusing 360? That is all you're doing, yeah? Right guys, I hope you learned something new today and you enjoyed the video. If you did, feel free again to subscribe and like the video, share it with your friends if you feel like it will benefit them as well, and feel free to follow me on Instagram as well. All the details are in the description below, and I look forward to seeing you in my next video. Peace.